Now to the flowchart of the program. Right here, at the center of the project is a Raspberry Pi 3 Model B. It will function as the MQTT broker and also host the Node.js server. The ESP32 will be the client that publishes and also receives data from the broker. Now on the back end, we have a Node.js server that is running with a PostgreSQL database. Because we want real-time communication between the server and the web client, we are going to use Socket.io. If you don't know Socket.io, that is fine. It allows bi-directional communication between the server and the client so that they can communicate in real time, just as you would do with instant messaging applications. Now, how does this entire project work? Starting from the ESP32 microcontroller unit, it will read the sensor values and publish the sensor values via a specific topic to the MQTT broker, that is the Raspberry Pi. The broker in turn will take those values and publish them to other devices. Any device that is connected on that topic will receive that data. So MQTT protocol is very easy and efficient. That is why it's kind of popular in IoT frameworks. Now, when the MQTT broker gets the data, it will publish it and also it will save the data in the database. Once the data is saved, we can retrieve it later time either via the web client, or even if we build a mobile application, we can just send HTTP request and retrieve the data that has been saved. By the end of this tutorial, you guys are going to learn a couple of things. First, you will learn how to set up MQTT communication among devices. You will learn how to create a Node.js server and incorporate Socket.io for real-time communication. You will also learn to set up and manage a PostgreSQL database. If this is your first time of hearing about MQTT protocol, you shouldn't worry. The MQTT, as we simply call it, is a message queuing telemetry transport, right? It is a lightweight messaging protocol designed for small sensors and mobile devices in low bandwidth and high latency. So mostly it is used in remote places where the networks mostly are not reliable, and particularly is very important in IoT applications. MQTT follows publish-subscribe model, where a client communicates through a central broker rather than directly with each other. So we have a broker which serves as a central point, and all the clients will be connected to the broker. So a client is the device that can, let's say, send message to the broker. For example, in our case, our client is the ESP32 right here. A client can also subscribe to a particular topic. Whenever messages comes in through that topic, the broker will send that message to those clients that are subscribed to it. A web application could subscribe to temperature topic to receive and display data in real time. In our case, we have MQTT client and also we have the web client. So the MQTT client will be subscribed to a particular topic. Let's say the topic is home/living room/temperature, and it will periodically publish data to that topic, right? The web client over here can also subscribe to that topic. So whenever the client, this one, publish the temperature data from the sensors, it goes to the broker and the broker will transmit it to the web client. Very easy. I've included materials in the description if you want to learn more about MQTT protocol and WebSocket. Let's go on. Let us write the program for the ESP32. Open your Arduino IDE and create a new sketch. We need to add the ESP32 board to the IDE. Go to Tools right here and go to Boss Manager. Search for ESP32 and you add it to the library. Once you are done, we need a PubSub client that is used for the MQTT protocol. Go to Tools, Manage Libraries. So in the Manage Libraries, type PubSub client. Can also install this. This will be the two installation that we will add. Leave some space and let's begin writing the code. Include wifi.h. We will also include the PubSub client. We include HTTP client. We start by setting up the credentials for the Wi-Fi and the MQTT. For the Wi-Fi, we will need the Wi-Fi name, the password, and also for the MQTT, we will need the server. Now the server is whatever network your broker is connected to. For the broker, I'm using a Raspberry Pi, and the Raspberry Pi is connected to my own local network. Now if you have a Raspberry Pi and you SSH into it, you can do if config to review the IP address. The next thing to do is to define the pins that we are going to use for the sensors. As we said, we have 4 sensors in this project: for temperature, for pressure, for light control, and also for air quality. This will be the pins for the sensors. We will set up the Wi-Fi so that the ESP32 can connect to the Wi-Fi network. Let's write a function here and call it setup Wi-Fi. It will return void delay for 10 milliseconds, and let's say we can print something connecting to something, the name of the network, and we will not leave this while loop until we are connected. We will call the inbuilt Wi-Fi while status is not equal to wl.connected. We will delay for about 500 milliseconds. If we are connected, then we can say Wi-Fi connected. Now we know that wireless connections can sometimes be unstable. We need to define a function whenever we are disconnected. The ESP32 will once again connect to the Wi-Fi. So let's just define something like reconnect. Loop until we are connected. In here we can do a while loop, and we call the Wi-Fi client. It's part of the library. Whilst we are not connected, we always attempt to connect. We need to call the ESP32 client. You pass this to it. We can print something. So once we get in here, we are connected. Other than that, we'll keep on looping. Once we are connected to the network, because we are dealing with MQTT communication, this is where we try to subscribe to a topic. In here, we can call the client.subscribe, and we will use this ESP CMD. So that is the topic, which means that the broker also has to create this topic and publish it for the client to be able to subscribe. If we get to this stage, it means still we are not connected. So fail to reconnect. Maybe we can print the state of the network. We will wait for a few seconds. We want to wait, so we call the delay function for 5000. That is exactly 5 seconds. If connection fails, it will reconnect again. Now we are going to write a callback function, and it's responsible for receiving messages from the broker to the client. We know that the client can transmit and also it can receive. So we call this function callback. We will pass the topic, the payload, the message that is coming, and we will also get the length of the message. Whatever message is coming, we can get it inside a string. We can do for loop here, length. We can add everything to the string, whatever the payload is. So let's say if the broker sends something like put off the fan, we will get that and we will turn it into a string. Then we can print the message. So now we have the message. We need to handle the message. First, we need to make sure that the message is coming from the topic that we are subscribed to. We will check the topic if it is equal to what we have subscribed to, right? And top here we said we are subscribing to this topic. So in here we will do ESP/CMD. That is the beautiful aspect of the MQTT protocol. You subscribe to something and you are waiting for messages through that topic. Once this if statement is true, this is a string pointer. Let's convert it to a string. Okay, this is accurate. Okay, so once this if statement is true, it means that we've gotten a message from what we've subscribed to. We can print receive message. Now, when we receive message, we need to call function to pass the message, right? We need to decode the message that is coming. Do this and we pass in the message. So let's come here and define the function. It will take a string as passed by the reference. Now the string that will come in will contain the name of the sensor and also the command. So let us find where the comma is, and we separate between the sensor name and the command. We call this comma index, and whatever string we get, we try to find where the comma is. So once we know where the comma is, we can use to extract both the name and the command. We create a string to hold the name of the sensor name, and we can use this Arduino command substring. We already have the index of the comma right here. So the first part of the string will be the name of the sensor, and as you are right, the second part is going to be the state of the pin, right? That is the command that we want. We will call this pin state, because basically all that we are doing is we are going to write a high or low to the pin that the sensor is connected to. So pin state is equal to string.substring, and this will be the command that comes after the comma. You will do this +1, and we convert it to integer. Once we have everything, we can print the sensor name and also the pin state. We have decoded the incoming string from the broker into the sensor name and the pin state. So we can go the next step and actually issue the command, right? We have 4 sensors, so we can make a switch statement, and we say that, for example, if the sensor name is temperature, then write the pin state to the temperature pin. This should be very easy. If sensor name is equal to temperature, digital, right, whatever value that comes in to the temperature pin. So we go the temp pin and you write the pin state. This should be easy. We will do it for the rest. We can also leave a space to handle unknown names that are passed, but we will leave that empty for now. That should be all for passing the string. So now we can come into the setup function of the Arduino code, setting up the serial.begin and 115200, and we can call the setup Wi-Fi function that we declared right here above, setup Wi-Fi. Now we can also set up the client for the MQTT set server inbuilt function. We call the MQTT server that we declare above, and it contains the IP address of the broker, and this is the default port that we use for MQTT communications. And we call the set callback. So in the set callback function, we pass in the callback function that we defined, which is this, receiving messages from the broker. Once we are done, we can also set up the pin modes. We will do pin mode. We set all the pin modes, and they are all outputs. That is all for the setup function. In the main loop, we try to maintain connection, or when we have a disturbance in the Wi-Fi connection, we will need to reconnect. So this is where we call the reconnect function we defined earlier. Inside here, we will check if the client is connected to the network or not. If he is not, then we call the reconnect function. Okay, and we will loop it. After making sure that our connection is intact, we can read the pins that the sensors are connected to, right? We could use analog in or digital in, but this time let us simulate sensor readings. So we are going to provide random values, right? So float temperature, let's give the temperature a value between 0 and 100, and we want it to be float, so let's do this divided by 100.0. We do similar things for the other sensors. This should work for simulating the values. Once we have the values like this, we will put the values inside a string, then we will publish it onto the topic. So the broker is already subscribed to that topic, and the broker is going to receive that. We call the payload, and we will use the inbuilt string function to turn the float values into a string. Once we are done, we can publish it. So we can do client.publish, and we need to indicate the topic on which we want to publish this. So we can call the sensors, and we call the payload. We use the inbuilt function str. We can also print to the serial. We call in the payload. Let's delay for about 5 seconds. So this means that we are going to send the sensor values every 5 seconds. If you watch closely, you can see something that we are publishing on this topic, right? But we are also receiving some values from the broker on a different topic. If you remember, this. Okay, so in this instance, the ESP32 client is publishing, and it is also receiving, because it is also subscribed to a topic from the broker. That will be all for the program on the ESP32 MQTT client. Let us move to the next. This is how our directory looks like. Inside the server, we have the node modules, public, source, and these files. Go into the source and into the configuration. We created this file db.config, but we need to rename it. It has to be db.config.js. So you can do the renaming here. We are going to set up for the PostgreSQL. We need to first give the credentials of our database and export it. Module.export, and inside this object we will give a few credentials. The user will be Postgres. We will add the host, give the name of the database. We will call it home. The next thing is to add a password. Just create any random password that you want for your database. I'll use this, and the port is always 5432. Once you are done, go to the modules, and inside the modules, the db.js. So this is where we are going to create an object that will help us to connect to the database. We are going to require the PG, that is for Postgres. And also we will get the db config that we just created. So let's try to access that config/db config. Constant pool, and we are going to create a new instance of this pool that we got from the Postgres. So you do this and you leave space. Inside here we call user, and the user that we created in the db config, we call host dbconfig.host database, call the password, and we call the port. You bring a semicolon. When the database is connected, we can print something. So on connect, we can write something to the console. Now in case there's an error, we can also print something to the console. Error on the client, you can print the error and exit. After everything, Node.js application, we always need to export, and this export will be the pool object that we created. This is a concise program here that will allow us to have access to the database. From this, in the same directory, I want you to go to the census.model.js. A module is going to describe the fields in our database and the operations that we would like to do in the database. So for example, we would like to insert something into the database. We would like to find something by an ID. We would like to delete. We would like to update. All those things we are going to describe in the module, so that later on we can reference the API and we don't need to rewrite the queries manually. We will call the pool that we created here. So on top, let's call constant pool. They are in the same directory, right? So db. The first function is we have to create the table that we want to have access to. When you go inside the database, we have tables. In case the table is not created, then you have to create it, and we call it create sensor data table. We have to make it asynchronous in case it has to wait for a response. Inside here, we will write a query to create table, and so we can do constant query like this. As a convention, we have to write in capital letters, but you can also write in small letters. We do create table, and the name of the table will be sensor data. We need to bring this. Let us define the fields in the table. So first, this sensor data table will have an ID, primary key, so that it will keep on increasing, and it has to be unique. We will have a field for timestamp, so that anytime that we send data, it will get the timestamp of that particular moment and save it in the table. We will call an inbuilt function called timestamp default now. Now the next field will be for recording the temperatures, and this will be numeric. We will create the field for the pressure, the field for air quality, and also for the light intensity, which will also be numeric. We will just call this function here. So this function will be called automatically in case the table does not exist. So we say create table sensor. Let's add if not exist. If we already have the table, then we want to create it again. The next function that we want to create is a function that will go into the database and query all the data that we have. So we can do const get all sensor data. Now we are going to do a try and catch. Let's put an error. If there is an error, we will throw that error, throw new error. Now inside the try block here, we can do constant result. We call the pool object and we pass in the query. We want to select everything. To do that, we write select star from sensor data and we will return all the rows. The next function will be to get a specific row of sensor values by the ID. Get sensor data by ID. It means that we have to pass an ID to this. Make sure you bring your semicolon. Inside here, we will do try and catch. So now constant result, we will do await pool.query. And this time, the query to select a row of data by an ID, we write select star from sensor data, where ID is equal to the ID that we want to add, right? We will do *1. We go outside here and we put this in bracket ID. Once we have this, we can do return. This time we only need one value, so we get the first row and we have to do the catch the error. Now, something that we would like to do with this project is that we want to enable the user who is accessing the web client to input a time range in which he wants to see the sensor data. So you go to the website and you type, let's say 1,5. It means that you want to see the sensor values that has been recorded between the past 1 hour and 5 hours. So let us write the query for that. We can say constant.get sensor data within range async. So this time we need to give it the time range that we want to query the data. Bring your semicolon. Let's do a try block here. We're going to do select star from sensor data. This time we will use the where clause. Now if we look at our database, you can see we have a timestamp field, so we are going to use that. So where the timestamp, we want to find the timestamp between certain period of time, right? Let's go to the next line and do timestamp between now, and we need to subtract. Let's get the time that we passed here. This time we get time end. So this is going to be an object. So that object will have a field that we call time end. It will be in hours. Okay, let's continue the query. Let's go to next line. Now we will get the time start. So now minus interval. We do the same thing. This time is going to be time start, also in hours, and we will bring a semicolon. This query will do that for us. It will get the sensor data within a specific range. So now we can get the result like we did for the previous. Await pool.query and we pass in the query. Once we get it, we can return the result, and this time it's going to be a lot of rows. We will return everything. Now let's catch the error. The next function will help us to insert sensor data into the table, right? And also we will create a function that will delete a row from the table. So the function to insert, we will call it create sensor data. This will be async. And when we are creating a sensor data, we need to pass the data that we want to create, right? So this is going to be a post request. You send a post request with the key value pairs. We will do this. Make sure you bring your semicolon. So inside here, we will try and catch. So we're trying, we need to get the query. We're going to insert into the sensor data table. We'll get the field that we want to insert to. We get the temperature field, pressure field, the air quality, and the light intensity. Now come to the next line and the values that we want to insert. The values we want to insert will be coming from this. So this is going to be an object. So we are going to call this object and we will get all the fields that we want to insert here. In PostgreSQL, you can just represent them with numbers. We have 4 values to insert. After creating it, we want to return the object that we created. So we will add this. Once you are done here, let us get the objects that we want to insert. That is the fields that we want to insert. Let's put them into like an array. We can do constant values, right? Going to be an array and we will pass the field from it. So this is temperature here, data dot. The next one is pressure, air quality, and light intensity. Now this, as I said, is going to be a post request, so make sure that the fields they match this exactly. Other than that, it will return an error. And we can do constant result, the same as the above. Await pool.query, and this time we will pass in the query that we just created above and also the values. So we get the results and we can return it. We are creating one object, so we get the first index and we throw it. The last function that we create is a function to delete a field in the database. So as usual, let's say delete sensor data. Sync. Now when we are deleting sensor data, it means we are going to delete a specific ID. So let us pass the ID here, except you want to delete everything inside the sensor data table. This is not what we want to do. Bring your semicolon. We do try and catch any error. The query is delete from sensor data, where the ID is equal to, we will return the row that we deleted. So bring comma inside and also outside, bring comma, right? So once we have this, we can do result. Once again, we call the pool object query and we pass in the query, and also we need to pass the ID that we want to delete. Okay, then we return it. We are only deleting one, so we get the first index. Then we can catch any error. So we can do module.export. So first we export the get all sensor data, get sensor data within the range, literally all of them except creating the sensor table, and also delete, comma. Now that is it for the sensors.model.js. From here we will go inside the services and we will write the code for the sensors.services. So the sensors.services is going to require the functions that we created in the model. That is why we exported it. We create all these abstractions and it makes it easy for us to manage the database. Go to the sensors.services.js, which is inside the services directory. Now that we are done with the sensors.model.js, go to the services directory that we created and let's write the code for the sensors.service. First thing that we do is to import the model that we defined. So we will do constant sensor model. We go to the model class, then we select sensors.model. We will define a service function for each of the models that we defined. What I mean is when you go back to service.model.js, all these functions, we need to create service functions for them. Starting with the first one, we begin by saying export. Now when we do the export, it means that we are exporting directly. The previous one, after defining the functions, we exported. But one way is that we can also do it directly. Export.get or sensor data. This is also going to be synchronous, and we do our try block. Basically, we are going to call the similar function in the model. So we will return sensor model. We call the get all sensor data. If there is an error, we will throw that error. So seeing that this is very easy, you can go ahead and do the same for the rest of the functions in the model. You can do get sensor by ID. Now because we are getting sensor by ID, we need to pass the ID whenever we call it so that we can give it to the model. Next function could be the get sensor within range, and that one we would give it the time just as we did here. It is this function that we are calling inside the service. Within range, we pass the time. The next function create sensor data. We can paste it, and when we create sensor data, we pass the data to it. Now we need to do the same for the delete sensor data. You can choose to write. The delete will take the ID. We have created the service functions for the models. So what happens is that we are not going to call the model directly. We can choose to call the services. Once we are done with the services, go to the controllers directory and let's write it. So just as we did for the service, we will now import the service. We can do constant sensor service. We will import from the service / sensor service. Now once again, we are going to write the controller for all the services. The controller is the functions that we use for routing. When somebody, for example, wants to access a specific API, get all the sensor data, then the routing file that we will write after this will route the request to this controller. The controller will call the service, and the service will call the model, which will execute the query. We use this abstraction in Node.js application. It makes it very easy. So we will do export get all sensor data, going to be async, but this time because it will be receiving the HTTP request, we will pass in the request and the response. So this time we are going to get something from the service, something that has to return. So we can say sensor data, and we will await, and we will call the sensor service dot get all sensor data. Once we have this, we can return the HTTP response that the request was successful. So we can do response dot status. Status 200 means that it was successful. We will send the sensor data in a JSON format. We can pass the sensor data just like that. Then we will catch, get any error. So we can use a response of 500. The request failed, and this time I can do a message. Then we will get the error.message. Now we are going to write functions for the rest of the services. So the next one could be get sensor data by ID, request response. We'll try. We will get the sensor data that we want. We call the await. Then we need to pass the ID. Now, if this is a request, then we will retrieve the ID from the parameters. We can do request.params.id, and that should be it. We can return the response 200, meaning it was successful. Then .json, then we pass in the data. If the request was not successful, we print the error. I use 500. And we can do the same. The next function, we can get the sensor data within range. We try. The data that we retrieve, we put inside a variable, this one. And if we look at the function, when we come here, the get sensor within range, pass the time, right? It's the function that was called here with time. So if we are calling it in the controller, then we need to pass the time, and this could be a post request. So we will get the body of the request. Can do request.body, then we can return it. HTTP status as successful. If not, error occurred. We catch it. We can create the create sensor data. Try. We call the function from the service. Create function. So the create is going to be a post. So we pass in the body and we return the request status. So after creating an object, whatever it is, it will return it. If not, then there is an error and we get the error like that. Need to remove this one. What is left for us to define will be the delete sensor data, and this one, it takes the ID of the row that we want to delete, and after deleting, it will return the row or the entity or the sensor data. Same process. We call the delete sensor data and we pass the ID, so we get it from the parameters. That is, we pass it in the get request. If not, an error occurred. Okay, so we have defined the controllers for this application. The next thing is for us to route everything. So if we look at how it works, the service calls the model, the controller calls the service. Now we will go and route the request so that when the request comes in, we can route it to a particular controller. So first, let us get Express, and we will also get the router, express.router. We will get the controller, so sensor controller. We go to the controller directory, we select this. We are going to route each request to the functions that we have created. So first we can do post. When the post comes in like this, then we will route it to sensor controller dot create sensor data. We can do a get request on this slash sensor controller get all sensor data. Now what this means is, for example, if we have a domain name, right, and slash, and it's a get request, then the request will be routed to this, right? We can do router dot, if we want to search, we can call the get sensor data within the range, so that will be a post request. If we want to get a request by the ID, so if a request comes in by this path, then we can get sensor by ID. The next is to route the delete. So if the delete comes in, the ID, we can map this to delete. When we are done, we need to export the router. This is very easy. So in the same directory, go to the index.js. Now, before we begin to write the entry point of our program, that is the index.js, we need to install something. When you look at our package, you can see all the dependencies that we have: Express, HTTP, MQTT, Postgres, and Socket.io. We need to make a last installment for EJS. EJS, embedded JavaScript. It allows us to embed data into HTML file. For example, if we query our database and we get rows of data, we can decide to embed it inside HTML. So go to your terminal and move back to the main application, that is the server, and we will do npm install EJS. Now the package is installed. It looked like it required root access. Open your index.js with VS Code or whatever editor you are using. First, we will get Express. We will get MQTT. We will make app out of the Express, if you know how Express works. Then we will get the port. As I said, we are going to run it on localhost, so we could make it port 3000. And this is the Node.js server, so that when you go into your browser, you can type http:// your IP address :3000. Then we can get the HTTP. To require HTTP. Next, we can get a server out of the HTTP that we created, the http.create server. And inside the server, we will add the app, this app that we got from the Express. We will get a path object because we will be serving static files on the web client. The next one, we will do this server and we will require Socket.io. We are going to use Socket.io and we need a server to do that. So once we have this, we can do io is equal to, then we call the server that we have already defined up here. So we create a new instance out of that server and we pass in the HTTP server, right? So we need to create a server for the Socket.io. Whenever a request comes in, it needs to be routed. Can define constant routes. We go back into the source, and source we get routes and you get the index.js. And the last thing, we can get sensor model, source models and sensors.model. We will set up the embedded JavaScript. We call the app.set. We call view engine, that is the default name for this, and we will use EJS. Now we also want to specify a directory which will contain the static files, that is our web pages. So we can do app.set. We need to specify from which directory we are serving our static files. So we will do views like that. Then we call the path object that we created, then join directory name, and we want to be serving from the public directory. We are not going to save every sensor data or row of sensor data that comes in. So we create a buffer, and for example, we will save about 5 minutes of data inside this buffer. After the buffer is completed, we will find the average and we will save the average inside the database. Let sensor buffer. We will set it to empty array, middleware to parse JSON data. We are going to use express.json. We call it like that. Now we will add routing here so that when HTTP request comes in, it will route it to the appropriate API. So we can do app.use. We will say like API, which means that whenever a request comes in and it has this after the domain name, right, then it will be routed to this. Now it's time to set up the MQTT. So we can just create a constant and call it MQTT client. And this one, we are going to call the MQTT that we created up here, this. So we do MQTT and connect. Now inside this connect, we are going to add this, and also we will add our IP address. Now the IP address that my Raspberry Pi has is this. Look at yours. You can go to your Linux terminal and type if config. It will show you the IP address. So we type in the IP address and we type in the default for. Once we have our MQTT object, we are going to define two main functions. That is when the MQTT is connected and also when message comes in. We will do MQTT client that we just defined above on connect. We are going to call this JavaScript function. For debugging purposes, you can print something to the console connected to MQTT Broker. So when connection is made, what we can do is we can subscribe to a particular topic. So we can do MQTT client.subscribe, and when we looked at the code that we wrote for the ESP32 client, we created this subscription home.census/data in case we catch any error. Okay, make sure you bring the semicolon here. We can print it to the console. You say failed to subscribe, we can put in the error. In case you have another topic, subscribe to a different topic. Now we will leave this entirely just as we've done for MQTT client.onConnect. That is when we are connected. We can also do that when message comes in, right? And we decide what to do with the message. We can decide to save the message, or also we can decide to send the message to update the web client, right? So we will do MQTT client dot, this time on message, right? So when we have a message, we want this to be async, right? So that it can work in the background. We pass in the topic and also the message. We need to make sure that this is the topic that we are expecting. For example, we might be publishing a couple of topics. So once we know the topic, then we can route it properly. If topic is equal to what we are expecting, this time we are expecting home/census/data, constant get payload string. And we will call the message and we will convert it to string. Payload string received. Once we are done, we can convert the string into appropriate format that we need. We'll be passing it as JavaScript object, an object that has the fields of temperature, pressure, air quality, and light intensity. We will say sensor data. We will create a function and call it convert payload string to object. We will pass the string inside it. Can do console.log sensor data, right? When this is complete, we can update the web client, right? And we said we will be using the socket IO for real-time communication for the web client. So the object that we created for the socket IO is here, IO. So inside here, we will call this emit, and we give a name for it, sensor data. The working principle of the socket IO is easy. All that you need to do is that you need to emit data and you go to where you want to get that data. For example, when we start writing the HTML, we will call socket IO object and we will do, for example, socket.on. Whenever we receive this on sensor.data, then we can retrieve this object. Okay, then we can decide to save the sensor data that we have received. That is the average. Save average sensor data. This function we've not created yet, but we will create. So we have two main functions that we will create. We have this to convert the incoming string to object, and also this function that will save the average of the sensor data that we have recorded over a period of 5 minutes. Move down and we need to define few endpoints. We will do a get request. When somebody visits the home like this, we want to see if the page is working, right? So request response console.log, we will say hello world, then we can return response. Then we can just pass a message like data received. Do app.get/graph, the request comes in, the response showing graph. After that, we are going to serve the request with the static HTML file. So we can do res.send file. We add the directory where the files are, and the files are located in the public/graph.html. I mean, when you go inside the public, we are going to create two HTML files. One will be graph.html and the other will be detail.html. In here, we will do app.get detail request response. We will do try because we will be accessing the database. So we say constant data, and this is why we define the sensor model. We imported it here. If you go up, you see the sensor model. We want to access the database directly. Sensor model, then we get all sensor data and we will send the response. Now we will be using the EJS embedded JavaScript. So with that, you call res.render, we give the file name. The data that we queried from the database, we want to embed it inside the HTML. So we do it like this. And that is all. Here we are assuming that you are using a template engine. After this try, in case we get an error, we will catch the error like that. Error retrieving data. We have to make this also async. The next thing that we will do is that we will create the connection for the socket IO. So IO.on, This time on connection, we will create an object and call it socket, and we will say that a user connected to socket IO. On the web client, the user will have the opportunity to either turn on or turn off a sensor, and we are going to use checkbox for that. We will do socket.on, and this time we will call it checkbox data. When such data comes in, we will get the data like this. Once we have the data that we want to send to the client, we need to call the MQTT client and we publish that data. So we can call MQTT client that we defined above, then we will say publish. Let's create a topic and call it ESP/CMD. Then we will pass the data that we received from the web, that is the checkbox data. And basically that is all. Whenever we get data from the web client, send it to the ESP32, and when it goes to the ESP32, it will take it and it will execute it. When somebody goes to the website and he goes to the detail.html and he wants to see the sensor data that has been recorded over a period of time, the web client does not contain the database. The database is part of the server. So what we are going to do is that we are going to use the socket IO to emit something to the server. The server will receive it and the server will perform the database query. Now when the server performs the database query, it will send back the results to be updated on the web client. Now we will create this socket and we will call it search time range. This is going to be asynchronous. We are expecting a search time from the user or the client. Inside here, we are going inside the database to retrieve the time period the user wants to see. Return data, and this time we call the sensor model and we will get sensor data within range that we defined, and we will pass the search time just like that. After retrieving it, we will emit it back to the client. So what is important is that you emit it on a different channel. So you use a different name, received range, and we will send the return data. So when we go to the client and we also do socket.on rec range, it will give us the data. That is the simplicity of using socket IO. We call two functions that we have not defined yet, so we can start defining them. So convert payload string to object. Go down here and let's create that function. So this function, as we define, is going to take as parameter a string. Okay, so we will pass a parameter like payload string. As we said, when we get the string, we are going to convert it into a JavaScript object. We will kind of split the string using the split command into an array. So now we are going to call the split function on the string that we will be receiving, which means that the four sensors that we have will be sending the values like temperature, pressure, air quality, and light intensity. So we will split them into an array and we will return an object. We can do return object. We give the field for the object. So let's say, but we need to convert them to float. That is how we define our project. The first value will be for temperature. The second will be for pressure. The next one will be air quality. The last will be the light intensity. So this function will pass the string and convert it to a JavaScript object. Delete this semicolon. The last function we need to define is the function to save the average sensor data. So scroll to the bottom and let's define the function async. We paste the name and it is going to take the data. Now first, let us push it to the buffer that we created. As we said, we are not going to store every sensor data that we get, but rather we will put them inside the buffer. And when the data is collected over 5 minutes, okay, then we will find the average and send it. We will do push and we push the data inside here. Now we will write our logic here. We are going to send sensor data from the client every 5 seconds. If that is the case, it means that we will have 60 samples in 5 minutes. Okay, so whenever we check the length of the buffer and it is greater than or equal to 60, then we can say that okay, we've collected data over a period of 5 minutes. So we can do if sensor buffer.length, right? If it is greater than or equal to 60. So inside here we will find the average sensor data that we want to save inside the database. So we will create the variables. We will start with the temperature, average temperature. We will call the buffer here, and we are going to use the JavaScript reduce function. We call the reduce, and we are going to sum all the temperature values. After that, we will divide by the length of the sensor buffer. So here we can put sensor buffer.length. Okay, now come back inside and let's write the JavaScript function to do that. We are going to loop through all of them and add the temperature variable, and we bring 0. What we can do is we can just copy it for the rest. You can copy and paste it 4 times. So when you come here, it will be d.pressure, average air quality, and the last one will be the light intensity. Once we have this, we can put them back into a JavaScript object and we call the API to save it. So we can do constant, maybe save object, temperature, we convert it to float as usual, average temperature, and we only want 2 decimal places. We will do the same for the rest. So this is the object that we have created. Then we can call the API to save it. After saving it in the database, it will return the results. Then because we are going to call the model to do that, we need to make it async. Then we will call the create sensor data that we created for the API, and we will pass the save object, save obj. Correct this one. Let's make it like this. So after saving it, we can print to the console and see if the return value was correct. Then after that, we need to clear the buffer so that it will store the next 60 row of values that will be coming from the ESP32 client. You make it empty. Alright, that is all for this. We just do server.listen. We created the port already. Server is running on this port. So this is all for the MQTT broker. Okay, so we are calling our MQTT functions and also the WebSocket that will communicate between this server and the client. The last thing that we will need to do is to go inside the public directory and create the 2 static files that we need.